1.3, solving linear systems by the Echelon method. We know from Algebra 1 class that 3 things can happen in a system of 2 equations with 2 variables. The lines might cross in a single point, in which case you'd have one solution. That's what seems to happen the most. We've seen if you get parallel lines, that means no solution. You need to know this word. When this happens, there's a special, it's called inconsistent. And then sometimes it so happens that the 2 equations just happen to be the same set of points. If that happens, then every single point on one of them is also on the other. And so we said that was many solutions. And that is a dependent system. So know those 2 words. That might be new to you, but otherwise you've seen this before. We're going to go way more into detail on the many solutions. So make sure you're paying attention to that. The Echelon method process works by producing equivalent systems of equations. Another way of thinking about it is trying to reduce the equations. So, for example, 10x plus 30y equals 25. If you notice, all of those numbers can be divided by 5. I could divide all those numbers by 5, and that would reduce down to 2x plus 6y equals 5. All I did was divide by 5, divide by 5, divide by 5. And the result is the exact same set of points. It's the same line if I graphed it, but it's just smaller numbers, a little bit easier to work with. That's kind of what we're doing. We're trying to reduce everything down to something a lot easier to solve. Row operations, this is kind of the rules of the game and what you're allowed to do. You are allowed to exchange rows. You are allowed to multiply an equation by a non-zero number. That's kind of what we just did, all right? Now, one thing to notice is there is no such thing as division. So technically, when I said divide by 5, in order to follow these rules, we would have said, instead of that, we would have said times 1/5. Now, in a practical sense, I don't think anybody in this room is going to think about multiplying by 1/5. We're all thinking about dividing by 5. So understand that that's pretty much the same thing, but division gets kind of wonky when we're talking about fractions. So we say multiply. Multiplying by 1/2 is the same as dividing by 2. And then number 3, we can also replace an equation with a multiple of itself plus a multiple of another equation. So that's where we're doing like row 2 plus 3 row 1, something like that. That's the rule, and that's probably the hardest part of the lesson is getting that statement right there. How to solve a system of equations by the Echelon method. Use row operations to produce triangular form. Use back substitution to find the values of the variables. So triangular form looks something like this, okay? We want the equation to be in triangular form, and what I mean by that is we're going to try to eliminate whatever entry is here and here and here. We want those gone. We want those to be 0. And so if they're 0, we would say it's in triangular form. So check it out. This system of equations is in triangular form right here. And as a result, it's much, much easier to solve. In fact, you might already know how to do that. Can you tell me what z equals in this system of equations? If you look at the bottom equation, you can divide both sides by -2 and see pretty quickly that z is going to equal 1/2. And then it might occur to you, well, I'll just plug that into the second equation. If you take that 1/2 and plug it into the second equation, you're going to figure out what y is. That's what back substitution is. I'm going to plug this thing in, actually, both of those equations, okay? But we're working backwards. And so that second equation says -3y plus 2, plug in the 1/2 for z, equals -2. And you can solve this. I'm going to go quickly. I assume that you already know how to do this. 2 times 1/2 is 1. Subtract the 1, it's -3y equals -3. Divide by -3, you get y equals 1. Okay? And we're going to take that, and we're going to plug that in. Back substitution. So in the top equation, the first equation, we're actually going to plug in z equals 1/2 and y equals 1. So that top equation is x plus 2, and then y was 1, minus 4 times z was 1/2 equals 5. And I've got x plus 2 minus 2 equals 5. The 2's cancel, I get x equals 5. And so my answer, I've got a solution at x is 5, y is 1, and z is 1/2. That's Echelon method, okay? We produce that triangle form because it's going to be easy for us to substitute at that point. Now, you may be thinking, well, why don't I just do it the way I learned it in algebra class? Okay, and that would be one thing you could do. There are other methods for doing this problem. All right, but keep in mind we are learning the Echelon method, so that's what we're practicing. You might know a totally better way. You might be able to see a completely better way to do it, but this is the method. Get that triangular form and then use back substitution. Okay, number one, you've got a system with 2 equations and 2 variables. So it's going to be way easier than the one we just did. But keep in mind, the first thing that we need is this triangular form. All right, we want triangular form. So kind of lightly draw through that and understand that this 3x right here has to go. We want to zero that out. We want to make that 0. And that's the hardest part for people, is they have to figure out how to make that 0. Not only do we have to make that 0, but we have to make that 0 using this 2x. We want to zero out the 3x, but we have to use the term that's on the diagonal of that triangle. All right. Essentially how it works is by finding a common multiple of 2 and 3. Your 2 important numbers here are 2 and 3, and you need to find a common multiple. I would try to find the least common multiple. So can anybody tell me the least common multiple of 2 and 3? 6. Very good. The least common multiple of 2 and 3 is 6. And so, don't write this down. Basically what I want is some kind of statement that says 6 minus 6. Okay? Any statement that produces 0 will be fine. You could say negative 6 plus 6. You could do some other common multiple. You could say 12 minus 12 or 36 minus 36. It doesn't really matter what your statement is as long as it produces 0 using those 2 numbers, 2 and 3. Okay? But I like this one because this one's probably the easiest one because the numbers are the smallest. Least common multiple probably going to be the smallest numbers. All right, so you need to come up with a rule using your row. All right, so remember that this is row 1 and this is row 2. All right, so focus. This is the hard part. In order to make this have 6 minus 6, or if you want to think about 6x minus 6x, it looks like we would need to take 2 of the row 1s, that would be 6x, and then I'm going to subtract 3, I said that backwards, 2 of the row 2s, and then subtract 3 of the row 1s. That's going to make 6x minus 6x. That's going to zero out. That's going to do what we want. Okay, so what I'm going to do is, instead of writing it like this, I'm going to write it over here. I want 2 of the row 2s minus 3 of the row 1s. That's my rule. And here's where a calculator might come in, especially one with parentheses would be really handy. I don't need to do anything to the top. So just kind of pull the top over. 2x plus 3y equals 12. It's the bottom equation that I want to change, and I want to change it according to this rule, 2r2 minus 3r1. So let's see. All right. Your R2 and R1 are going to be the numbers that we plug in. They're the numbers from the equation. So when I plug that in on my calculator, I'm going to put those inside parentheses. Your rule says 2 times whatever's in row 2, which in this case, that number is 3. So 2 times 3 minus, and then your rule says 3 times R1. So 3 times the number that's in R1 is this 2 right here. Now that's 0, and we knew that was going to be 0. That was the whole point of picking that rule. But I'm just showing you the math here, all right? And I'm going to put a little dot right there just to hold its position. That's what goes right there. Is nothing. It's 0. But I'm going to use that same rule 2 more times. So start with the -4. Use the rule. The rule says 2 times that -4. So 2 times my row 2 number minus 3 times my row 1 number, which was 3. You should have gotten -17. Practice with your calculator. Make sure you're getting the same thing. If you can do this in your head, then awesome. Sometimes it gets kind of tough. So -17 y. That's my number for my y numbers. Now I keep going and I do the 1 and the 12. So remember what the rule says. It says 2 of the row 2 number minus 3 times the row 1 number. And we should get -34. -34. And -34 is actually a good number here because it's going to come out nice. I've got my triangular form. That's triangular form. That's what we want. If you've done it properly, if you've done it correctly, then that last equation should be an easy solve. Now, it might be fractions. This one isn't, but there's no reason why I couldn't give you a fractional answer. I just didn't here. Divide by -17, and you're going to get y equals 2. Everybody see that? Divide by -17 to solve this equation. You're going to get y equals 2. Question? Now I'm going to use back substitution. I'm going to plug that in right there. Back substitution just means plug it into one of the equations above. So that top equation says 2x plus 3 times y, but y is 2. So I plug in a 2. I'm plugging in a 2 for y in that top equation. 2x plus 6 equals 12. I'm just doing my basic algebra, isolating the variable. I'm going to subtract the 12 over. So 2x equals 6. Divide by 2. X equals 3. Got it. We've got one solution. And that point is 3, 2. One solution at 3, 2. Now again, you might know a different way of doing this problem, but I don't want you to go back to Algebra 1 and do elimination. Yes, I know you know how to do that. Okay, we're working on Echelon Method. Number 2, same thing. Look at your triangular form. Understand that we have to knock out this minus 4x right here. In order to make the triangular form, we have to knock out the minus 4x. In order to knock out that minus 4x, we have to use this number that's on the diagonal, 2x. And so the secret is find the LCM. What's the least common multiple of 2 and 4? 4. That's going to be the easiest path to go by. Okay. So I want a statement that says 4 minus 4 or -4 plus 4 or really anything that's going to work and make 0. If I do, let's see, this is row 1 and this is row 2. If I do row 2 plus 2 row 1s, that's going to say -4 plus 2 times 2. That's going to do it. That's going to make 0. All right, that's what I'm looking at. So again, just the top one we don't do anything with the top. Just leave it alone. 2x minus 3y equals 6. It's that bottom row that I had to change because I'm trying to zero out the -4x. So again, if you need a calculator, just make sure you're using the rule in the right place. So R2, that number is -4, plus 2 times R1, that's 0. Well, we knew that was going to be 0, right? So I'm just going to put kind of a placeholder, put a little dot there in that position just to show that we did that when it's 0, it's done. Now we move on, and we're going to do the Y column. So the rule says R2. What's the R2 number for Y? 6. Plus, the rule says 2 times R1. And what's the R1 number for Y? -3. Ew, that's 0 as well. So this one's going to be weird, okay? I can see right now that I'm not going to be able to produce that triangular form, but that's okay, because remember, there are other possibilities besides one solution. We might have no solution or many solutions. So we're going to keep going and see where this one leads us. Use the same rule on the last column. So I've got my row 2 number is 8, plus 2 times my row 1 number is 6. That's 20. And so over here, I've got this, okay? And you can see that the triangular form isn't going to work. And especially what you can see at the bottom there, that second equation essentially says 0 equals 20. 0 equals 20, all right? And that gets confusing for some people, but you got to really think about what a solution is. When I ask my students what's a solution, 9 out of 10 will say it's the answer. And that's right, but it's not good enough, okay? A solution in algebra, when we're talking about equations and stuff, a solution is something that makes a true statement. If you take a number and you plug it back into the equation, you get a true statement, you know that's a solution, right? So you're looking for a true statement. Well, 0 equals 20 is not a true statement. That's a false statement. And it doesn't matter what X is, what Y is, whatever. You plug in any number you want, you're never going to change that false statement into a true statement. Okay, and so if you can't ever possibly get a true statement, then that implies that this one is going to be no solution. All right, this is no solution. Also, you've got this word inconsistent. Inconsistent systems have no solution. All right, so let's do another one, number 3. Same thing, we're looking for the triangular form. And same thing, we still have to knock out this 4x, but we're going to have to use the x to do that. And so the people that really struggle with this lesson are the ones that can't find that rule. All right. I know this is a 1 right here. You don't need to write a 1 there, but you have to have a GCF of 4 and 1, basically, or LCM, sorry. LCM of 1 and 4 is 4. And so that leads you to your statement that's going to end up saying 4 minus 4, or 4x minus 4x, or something like that that's going to make 0, but that's probably the easiest path to go by. 4x minus 4x, so that should lead you to your rule. The rule I would use, anybody got it? It's going to give me 4x minus 4x. Nobody? Row 2 minus 4 row 1s. It's not the only way to get there, but I think that's the easiest way to get there. Row 2 minus 4 row 1s is going to be 4x minus 4x. It's going to make that 0. That's the whole point. That's what I'm trying to do. Top row, don't do anything to it. It's fine. Leave it alone. But the bottom row I need to change the bottom because I'm trying to knock out that 4x. So row 2 is my number 4 minus 4 of the row 1 numbers. Remember that was 1 because it's 1x, and that's 0. Okay, fine. So just a little placeholder. And then we apply the same rule to the Y column. Well, isn't that going to be the same thing? 4 minus 4 times 1 for the y column, that's another 0. Okay, so is it going to be the same thing? We'll keep going. You're going to have to do 40 minus 4 of the 10s. And those of you that can do that kind of stuff in your head have a little bit of an advantage over those that are reliant on your calculator. But either way, you got to be able to get there. So that's going to be 0 as well. And so that's kind of weird. You can still see, yeah, we're still not going to be able to do the triangular form. It's not going to work. But the difference is that bottom equation says 0 equals 0. And if a solution produces a true statement, that's a true statement right there. And it doesn't matter what x is or what y is, okay? You're always going to be able to come back to that true statement, okay? Whatever x number you pick and plug in, you're going to find some y that makes a true statement. And so that's where we say many solutions. Or we say the word dependent. Dependent systems. Now, a parameter is a variable that's used to help represent many solutions. And people, this blows people's minds, okay? When we say many solutions, this does not mean all real numbers, all right? That's not the same thing. You can't use those two interchangeably. Many solutions mean there are a lot of different things, but there is going to be some kind of special pattern. There's got to be something special about it. So let's look at this one. All right. Essentially what happened with many solutions, and you know this when you graph it, if you have two equations, but it turns into one line, it turns out that you really only have one equation. And so in this case, x plus y equals 10. Let's look at it. Try to think about some of the solutions. We can kind of make a table and just kind of look at it. If x was 1, in order to make this work, y must be 9, because x plus y equals 10. If x was 2, then y must be equal to 8 in order for that equation to work, right? If x was 17, then y must equal -7 in order to make those two things add up to 10, right? And I could go on and on and on forever and come up with many, many, many of these solutions, right? But I don't want to. I don't want to list them all out. I don't want to go write down forever. And so we use a parameter to kind of come up with a formula for the solutions. And so how that's going to work is like this. We're going to say, well, whatever x is, we're going to use x as our parameter. But what we can do is kind of just put y in terms of x. And so if I isolate y, what I've got here is kind of like a formula for the y value. If you give me x, then I'll give you y based off of this formula. So y is just 10 minus x. And if you think about it, any number you plug in for x, all right, so let's say x is 2. Well, then the y is going to be 10 minus 2 is 8. Yeah, that works. Of course that works. I'm just using the equation to have a formula for the solutions. So you'd have many solutions, but those many solutions aren't just random. Those many solutions are all going to have this form, and that's what a parameter will do for us.